Hi guys, and welcome to lesson 2.03, Introduction to the Periodic Table. What we're going to do in this lesson is we're going to kind of look at the overall structure of the table and the big divisions, and then we'll use the next lesson to talk about more of the individual groups and the families. Well, first of all, why is it called the periodic table? Well, it turns out we have 7 rows, and each of the rows is called a period. So that's where the periodic table comes from. The columns are called groups or families. And the reason they're called that is these columns share traits that are very similar. Just like your family, you might share the same shape of nose, or the same height, or the same shade of skin. These families on the periodic table have behavioral traits. So they might be unreactive, they might be really reactive, they might be good conductors. We have a line, so the first thing we're going to want to do is to put in a line underneath boron, between Al and Si, which is aluminum and silicone, between SiGe, down between Ge and As, which is germanium and astatine, in between astatine and antimony, down between Te and Po, and down. We have around this line some special guys. So I'm going to put in the corner like you score up your bowling score. I'm going to put a little corner symbol. You can see what I'm doing here. So it could maybe, and I can outline them too, that would help. Everything to the, let me switch colors. Everything to the left of this line are considered to be metals. So everything from tin to nickel to vanadium to hafnium to yttrium to calcium to sodium. Wait, sodium, that's the stuff on my table. Turns out it's actually a metal, and in a few chapters you'll get to see what elemental metal sodium looks like. The only guy that's kind of weird here is hydrogen. Hydrogen's a gas. Hydrogen's kind of like that odd puzzle piece that we can't find the box it goes to. It's on this side of the table because that's where its number of protons says it needs to be, but yet it doesn't really act like a metal. So hydrogen's always the odd man out. These are arranged by the number of protons. Remember in the last video we said protons are always going to be P+. So hydrogen has 1, helium has 2 protons, lithium has 3 protons, beryllium has 4. That's also the atomic number. Everything to the right of these boxes are nonmetals. Nonmetals. So from carbon to phosphorus to selenium to iodine, radon, we only have, so what we have, like 5, 6, 7, 8, 9, about 12 or 15 nonmetals. Everything else are metals. Well, what's up with the boxes then? Everything with a box is a metalloid. So what's the distinction? What do we actually, why the differentiation? Metals behave a lot like you would think of copper or zinc behaving. They conduct electricity well. They have low melting points. They you're able to bend them. Nonmetals don't have any of those properties. In fact, a lot of these guys, these are all gases. These are usually gases, but now we've got, these tend to be solids. So we don't have very many solid nonmetals, but these guys don't conduct electricity. They're a different, usually, state of matter. Metalloids have the abilities of both metals and nonmetals, so they combine abilities of metals and nonmetals. I think I went off the page a little bit there, but that says nonmetals. And you are a lot more thankful for metalloids than you realized before we started this lesson, because what you probably did not know was that it's metalloids that allow you to instagrams, because the problem with traditional metals is they have a really low melting point. So if you try to create an electronic device based only on metals, it can only run so fast and for so long. But because metalloids have a higher melting point, especially silicone, it allows us to have things like smartphones and iPads. There's a reason why out in Washington and Oregon they call it Silicon Valley, because all of our modern day electronics are built around silicone. It's probably one of the most important metalloids that we have. But in case you can't read this table, the metalloids are B for boron, Si is silicone, Ge is germanium, As is astatine, Sb is antimony, Te is tellurium, Po is polonium, and I'm sorry, As is arsenic, At is astatine. Whoops, that was my bad. So you need to know for a test, for example, if I asked you about silicone, that it's a metalloid, and that palladium is a metal, so you should be able to find palladium, that sulfur is going to be a nonmetal. Well, what's up with these guys down here? On the previous page, you have a periodic table, and I'm going to try to kind of freehand sketch this. I'm going to draw, come down here like this. If we took a regular periodic table, it would look like this. Where this section here is actually here. This is really difficult to fit on a single page. And so what most tables will do is they will cut here, and they'll cut here, and they'll swing it out and put it underneath the rest of the table. So these are, in fact, they're to the left of that metalloid line, so these are considered to be metals too. On the first lesson, we talked about the fact that some of these nonmetals are special, and I'm going to go with green. So we said 7 of these nonmetals are what we call diatomic. And we listed them out. We said it was hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And we said that if you, whoops, H and O, I'm cutting off, so I lost some of my, let me redo this, antimony, I have to rewrite down here, tellurium, polonium, astatine, and over here, HNO, F, Cl, Br, and I. And the way that we write these as 2 is we put O2, H2, N2, F2, Cl2, Br2, I2. Well, there's 7 of them, and check this out. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen is over here. Again, hydrogen not following the rules. But this makes a number 7. So if you can't remember, just remember 7 and 7, with hydrogen being the outlier. But you guys need to get this memorized pretty early on in the game, because you have to know that when boron's by itself, it's just boron. When silicone's by itself, it's just silicone. But if chlorine is by itself, that's going to be Cl2, Br2, I2. All right, finally, we have another distinction that we need to make. I'm going to outline 2 of these sections in red. Oh, we already used red. Shoot. Well, you'll have to bear with me. The first 2 columns and the last 6 columns are called the main group elements. Everything else, so here in the middle, are non-main group elements. And on a periodic table, what you'll often see is at the top of these columns, and you can barely see it here, there's a Roman numeral 1A, there's a Roman numeral 2A, over here is Roman numeral 3A. So you'll have Roman numerals followed by the letter A, 1A, 2A, etc. And the non-main group will have Roman numeral 1B, Roman numeral 2B, etc. So we make this distinction because the main group elements live very different lives from the non-main group elements. If any of you have ever visited another country or been to somewhere like Germany and driven on their interstate, you'll know it's called the Autobahn. The Autobahn, driving on the Autobahn is very different from driving on 75 here in Ohio. In Ohio, the speed limit is 70 miles per hour. In Germany, on the Autobahn, there is no speed limit. Or, for example, if you went to a bar in Germany, most of you would be able to order a beer because the drinking age, I believe, is 16. But in America, you have to be 21. Well, that's a little bit like what the main group and non-main group elements are like. The main group elements are under a pretty strict law called the octet rule. The non-main group elements, they kind of get to do what they want. They live a little bit more of a free lifestyle. Again, that's coming down the road. We'll talk about that later. But for now, we need to know that there's a difference between main group and non-main group. So, if I asked you to give me an example of an element that is a metal and in main group, can you think of an example for that? I'll pause for a few seconds. All right, so to answer that question, you would want to go with one of these 2 columns because these are main group elements and these are also metals. If I asked you for one of the metalloids, you could tell me boron, silicon, germanium, arsenic, antimony, tellurium, any of those. If I asked you for a metalloid that is next to a diatomic, so if I asked you for a metalloid that is next to a diatomic element, what would your answer be? Let me pause. The answer is there are 2. So here are my diatomics. So I have iodine, so you could say tellurium or astatine are next to iodine. And that's what you're going to see on the test is I'll give you a bank of elements, and then I'll have descriptions. And so if I gave you palladium, you would have to tell me it's a metal, and we're going to learn that it's specifically a transition metal. If I gave you sodium over here, you would have to tell me it is a main group element, it is a metal, and we're going to find out the name of this group later is called the alkali metals. So that is a quick introduction to the main sections of the periodic table. Thanks for watching and have a great day.